Okay, now this is going to be based on the Simulation Express, but to use Simulation Express you've got to actually make sure you don't have Solidworks simulation turned on in here. So because apparently it'll override it or something. So yeah, so I mean you just got to make sure that's turned off. That's probably why I had some of this turned off by default, because of that. So anyway, okay, you select Tools, Simulation Express, that opens it. I don't know what this is, Office Toolbars, I don't know what that means. Loads or unloads the SolidWorks simulation add-in, but it should be unloaded, so that's what I don't quite get. It says it's unloaded, so I don't know. Oh, okay, now it's updated. Alright. Now we're to the wizard. Okay, I clicked options there, but this is the wrong fucking folder, of course. Ah, shit. Okay. Okay, this is where I want it. Okay, for this tutor, they wanted me to set it to inches IPS, which I kind of prefer SI, really, but especially for physics and all that shit. And I'm supposed to click this, and OK, and next. But this shows you, what the differences between SI and English is. So, loads are in pounds. And PSI, I actually kind of prefer these two units. The ratio, thick yield, yield strength, and PSI. Really, a lot of these units I actually do prefer the English. Okay, and keep in mind, this is a wizard. It does have its own little design tree over here, if you noticed. Okay, we're going to apply a fixture to this face, and this means this is a point of support. That this warning says, that it can cause unrealistic results. Like you look where the hole is on this part, you can see that it's, it's the point where the fixture is applied, it may not be that realistic. And same here, for this little graph, you can see the fixture's at the bottom, that's where it's being fixed, so that's a little unrealistic. And then right here, the fixture, are at either end, so again, it may be a little unrealistic, on those areas. So anyway, we're going to add a fixture. Okay, and it's giving you a nice animated. Hell, at least these things are animated. But at any rate, I'm going to click the face of the hole. It's right there. That's going to be a point, deviation. It'd be kind of cool to try this one. Okay, so that gives us our fixture indicator right there. So it's showing it's fixed along that face. And then we want to, let's see, you can go back or start over or whatever on the step. Edit an existing fixture, so we can go back and edit it. But we want to hit next. Alright, now we're going to apply some forces, and I don't know why they renamed the standard planes, but anyway, just keep that in mind. This is like the top plane here. But we're going to go add a force. Okay, and in our faces, we want both this face and this face, and we're going to apply a 3,000 pound force, but since we got two faces, we're going to enter 1,500 pounds for each face. Okay, I don't know if this fucking recorded, but we're going to apply a force, and I selected these two faces, 3,000 pounds, but we're going to split it between the two faces. So I chose this select direction instead of normal because these are curved surfaces, and I selected plane 2. So I got to come down here and type 1,500. Okay, but I got to hit reverse direction so it points down because we want it to be a load, and we got it fixed up here. And then hit OK. If you notice, we have check marks up here for fixtures and our loads, so these are all the steps in the process. And you can see that force we just applied is here, and here's our fixed point. So now we got to go to the next step, which is choosing the material. So I'm going to hit click select material, and we're going to go choose basically alloy steel. That just happens to be, I probably ran through this tutor before. So steel, alloy steel, and these are all its characteristics. So hit apply and then close it. So it does work with the standard materials. I was kind of wondering that. So anyway, I'm wondering if I should turn real view graphics off for this or not. It might show up better. I don't know. I'll leave it on for the moment. So, alloy steel, did pop up there. We got a check mark on it. It's got a Young's modulus and yield strength here. So, we can hit next. Wait. Okay. Then the run step appears. Okay. So anyway, I'm going to go ahead and click run simulation. And it basically meshes the whole thing. I still wonder if I should turn that real view off. I don't know if this has got real view on though, actually. Anyway, I guess it's showing you the deflection. And it's if it's asking you for a survey. Yeah, real view graphics doesn't factor in here. Okay, but now let's go to the next step. Okay, based on the specifications, it's given us a factor of safety of almost 7.6, meaning that this material we got and the shape of the part and everything for the applied force is about 7.6 times sturdier than we need to actually support this kind of load. And that means, you know, that really it'd be about 7.6 times 1,500 pounds, apparently. So about 11,400 pounds is what it could support. Because it calculates, I guess, the factor of safety on a per face basis. So but at any rate, you know, we can look at you know, where the factor of safety is below 1, which means that it's failed, and it hasn't failed. We can look at the displacement, you know, so this is showing you, you know, areas of maximum displacement in inches. You know, still not a very large displacement here, because that's 0.013. I wonder if you can reformat this. I guess not. But at any rate, that's 0.013 mil. I mean, yeah, about 13 mils, you know, of maximum displacement. And it's even less down here, you know, about 3.9 mil, I guess. What the fuck does that mean? I don't even want to figure out what that means. I guess that's way, way less. Anyway, this is down to about 1 mil, you know, up in these kind of bluish areas here. You know, we can look at the von Mises stress. So this, you know, shows you where, you know, the maximum stress points are in PSI. So, you know, rather surprised at that, but then again, not really, because our load's applied here. That's going to be, you know, wanting to really deform it most here, you know, so that's where maximum PSI is going to be in this part. The maximum inclination to break, if it were going to break, it would break right around here, because that's where maximum force would be applied, you know, due to the torque applied to it and so forth. But you know, you'll have note, you know, this is displaced value. So, you know, if we go back to this, you know, that's the displaced value. So you can see, you know, when we animate it, you know, how the stress comes to be applied, you know, and I guess that's, they're just gradually applying a load to this damn thing or something. I mean, I don't know. You know, I doubt that they're just dropping it on it, because that would be an impulse. So, and that's why, to me, I would feel happy with a safety factor of 7, you know, because of the fact you start dropping loads on it, and well, that impulse can certainly exceed that, you know, that safety factor. So anyway, you know, you can also play it with the displacement too, you know, so you can kind of see it, you know, changing colors, you know, as it moves. Okay, now we're going to go back to the run step and change our settings and change the mesh density. Hit OK. What the? Oh, I didn't see this over here. Okay, I'm supposed to take this right to the right. Hit OK. Then run the simulation. Mr. Anderson. That didn't take long. It's much higher, you know, stress applied here. So, I mean, much higher resolution mesh. So let's see what the safety factor is. Still about the same, but it's you know, it's gotten a little better, in fact, for us. So it's pretty cool. And let's say the difference, you know, since it's small, it's like 7.6 versus, like I said, almost well, you know, anyway, it's a small difference between the two, so it implies that the results are fairly accurate, because, you know, kicking it up to much higher density mesh usually yields more accurate results. If there's a large variation, you know, you start to kind of wonder if there's something that's amiss. You know, I'm not sure, but we might have, you know, when we were first setting this up, we might have been able to specify, you know, how these appear, but I doubt it. I don't recall it being that complicated. Or not complicated, but offering, you know, that many options. You know, the von Mises stress is really only an equivalent stress. It's not, it doesn't, you know, precisely define the stress at a given point, but still it gives you enough to, you know, calculate, you know, a safety factor, because when the stress, you know, exceeds the safety factor times the load applied, you know, it's considered to be a failing part, you know. So in other words, if it's below 1, you know, it's considered to fail. At 1, it's on the verge of failure. So anyway, it's just something to keep in account, you know, take into account, because again, you know, Solidworks Xpress only deals with von Mises, so you're not going to, you know, see, like, you know, you can't like put a sharp load in it or anything, I guess. So anyway, let's see what the, you know, shearing action is and all these other detailed stress calculations. Okay, but done viewing the results, and we could, you know, generate a report. Oh shit, I guess I can't do it. Maybe I can generate an e-drawing report. Yep, that's where we're at. Okay. Alright. Oh, good. Alright, cool. Well, at least it works in e-drawings, so, you know, e-drawings, we can look at it in 3D, just like in Solidworks. So, displacement, deformation, factor of safety. I don't know if we can play an animated version here or not, but couldn't do that in Word either. Well, let's see. Oh, I guess it's just animating my moving the thing. I don't know. Well, no, it's not. Well, anyway. Alright, now I can, you know, exit it, and, you know, I can save the session. So, you know, if you open the part and run Simulation Express, you know, it'll already be completed. So if I come into Tools and run it, you know, we're already loaded, I suppose. Now I can go look at the results. will have to redo the simulation though, so. Okay. And it saved it. Alright, for this I changed to MKS because this is going to be in an MKS simulation. We're going to create a custom material apparently. And by the way, I just set it down here, so. Okay, so anyway, edit material, and we've already created these folders from CTC materials. That would be fine. Oh, still like materials. I guess I already did this. That's why it says CTC. Anyway, still like materials. We already got steel 1, which is what they renamed, and they changed the elastic modulus to 1.2. That's weird. Okay, it's supposed to be 1.2 to the 11th. That was set wrong. Poission's ratio 0.3. Actually, I forgot how you pronounce that. It's not Poisson. Anyway, okay, density 7,500 kilos per cubic meter, I guess. Yield strength 5 to the 8th. Oh, this is wrong too. I'll bet you it's this way because temperature dependent. But I'll bet you these are changed because I'll bet you later on in the tutor it gets changed. Anyway, save, apply, close. Okay. And now steel 1 is our applied material. At any rate, if we created the material, we would have just copied it, out of steel. In fact, I'll go ahead and do it just so I don't cheat you out of it, like alloy steel, for example. Control C-ing it, and Control V-ing it, and rename it steel 2. So, this apparently, well, it's similar, but it's, it's a little different than what I just put in. It's a little different than this material. So you can see what the differences in properties are. Well, they're about the same, except the density is a little different. They're both E to the 11th. Except I still don't know how that got set to the 17th. But it's 1.2 versus 2.1, so there's significant differences in the material. So anyway, oops. Yeah, I want to say that. Okay. Okay, and for reference, it's under, Simulation Express Wizard is on the bar. It's just in the Evaluate tool. And I was looking at the Office products and before for it, but I figured it might be in Evaluate. I know I'd seen it somewhere. Anyway, click that, and click our options. And like I said, there's not much options here, but we want to change it to SI. And the job training. Yeah. Man, I have to go through this. Hold on. Man, this directory thing sucks. God, I fucking hate these kind of fucking directory trees. And I just hate them. And they really bite. So if you're a programmer, never ever fucking use these. They suck. Big donkey balls. Shit. Fucking, I'm just gonna leave it there. They're basically all the same. Okay. Let's hit next. Oh. You want to add a fixture. You want to select this ring here as our fixture. And add a force. Let's see. From the looks of it, we're supposed to select this right here. So I guess there's going to be an upward force on it. And just like the last one, since it's curved, we want to this time select the top plane. It hadn't been renamed. And we want to go 4,000 newtons. And, again, since it's upward, that arrow's fine. We've got our loads defined, so we can click next. Okay, since we already selected the material, we'll go ahead and hit next and run the simulation. Okay, that looks good. So, yes, continue. Okay, we got 6.5 as a safety factor. Which isn't half bad. So it's applying it upward. Maximum displacement. I'm not having any yield issues with it. So and of course, I guess we could enter different safety factors here. For example, say where it's below 7, for example. So this is a way of filtering out the stresses. One's more than enough, for safety, but if you're interested in filtering some of those stress plots out, it's a way of doing it. So, if I put like 8 in here, you can see that region increase. So basically these areas in red are critical, but like, we could remove material, from areas that are still in blue because they have a safety factor much greater than 8. So, I can enter 10, and, that shows you, really this could be smaller, and even this area could be smaller. Although, remember, around this point, around this point, though, you gotta take it with a grain of salt, because that's where we're, it's like they said, the animation, data around your fixture point, is not necessarily accurate. But certainly through here and here, it could be increased. Decreased. The material could be removed. So what we're going to do is we're going to go actually edit this Cut Extrude Feature. Okay, instead of going blind, the distance of 0.005 meters, 5 millimeters, we're going to go through all and click that. If you want to view it, study to find. That's what we just did. But we got to rerun the study. So yes, continue. Okay, so now, we only have a safety factor of 1.5 or so, which that ain't so great. Come on, you fucking piece of goddamn shit. Idiots don't even know how to do a text box. So we do have some areas that very well could fail, so now let's see what happens when we press next. So I didn't do that. It says optimize your design. Yeah, let's see what it does. I don't know, I guess it can't handle anything here. It's in part of the tutor, but let's see. Yeah, well, I don't know what this is really doing, so I'm just wasting time. I've been clicking next, you know, it gives me a range. Factor of safety is a constraint. Say a minimum of 2 is what we're after. Next. Okay. I don't know what it's going to do within that range. It's running a simulation, the variation of widths, trying to find out which gives the best factor of safety. But the best they could determine, you know, was the factor of safety of 1.5, 1. I guess that's what that means. Okay. Which dimension value would you like to use for the model? Okay. Why do I have to rerun this? Okay. I guess that's good. I don't know. We don't have the results though. Oh, fuck it. I don't know what the fuck this thing's doing. Okay, basically I had to stop out and start it over again. Yeah, now we do have our new factor of safety, so it did work. It did optimize the design. I don't know why it kept asking me to do it over again, but I couldn't get it to work. But I finally stopped out of it, saved the simulation, and just started it again. So, but it looks like it's you know, got a better factor of safety here now. That's cool. So anyway, that was one way. You know, you could change basic parameters. If that wall were still in there, it probably would have reduced that, you know, to get it down to an acceptable factor of safety, as opposed to us just deleting the feature like we did. Alright, I guess here, you know, you gotta, they're not really going to walk you through the study detailed in a detailed way, but they're just telling you what to do. So let's you know, specify material. Wait, I'm going to save this. Let's see. You know what? I'm going to go ahead and I don't know if I can do that here. I usually can't. But I'm going to try to add this to the favorites. So yeah, so I can come back here because I may be referencing this a lot. Folder, see, shows that these are just part of the first series, and I'm just going to put all these in the same area. Okay, so it's assign a material. We want to assign nylon 6 out of plastics. On 610. We'll just keep with that default material. Alright, so let's go ahead and run the simulation Express. Go into options. Okay, we're going to go back to IPS. You know, shit, I don't know if I got this set right. Yeah, good. Okay. Hit next. Okay. So we're going to add a fixture. The fixture is going to be these 4 holes on the same selection. Apparently you can add more than one set of fixtures, so to a single deal. But those are going to be our points. That's where screws will be applied. And this is a hook. We're going to apply a force. Let's see, we can still add another fixture if we wanted to. Well, we're going to add a force here. Okay, but we're going to specify the direction. So that has to be the front plane. It's going to be a 350 pound force. But the arrows are going the wrong direction because this load's going to be applied this way. This will be like, think of it as being on a wall. Talking about show to verify load direction, but okay, let's see, finish adding the force, click next. I already got the material, so let's run the simulation. Okay, stop animation, continue. Factor of safety is 6.5, but it's pretty damn good. That means it can support way more than, you know, what sucks is I really don't know how big these parts are. I can measure it and I'm trying to find out. It's a distance of, you know, wow, really? That doesn't sound right. Oh. Point to point. Oh. Okay, it's you know, the length's 1.8 inches. I need to get more experience at using this damn thing. But so it's almost 2 inches by, I guess, 3 inches. So, man, it's hard to believe nylon could hold 350 pounds times 6. Anyway. Okay, but basically that's a constraint of SolidWorks Express, or Simulation Express, is that, you know, it can only simulate a single part, whereas the simulation can, the regular simulation package can simulate the whole, an assembly. Okay, I've already added fixtures to these two, and I've applied a force to this face pointing downward, so it's axial of 500 pounds. I don't know why they didn't apply it to this face, but I don't know what's going in this, but that's just kind of weird because it would just cause something to want to slip out of it. Okay. Wow. Now it looks like this sumbitch will fail. You know, the amount this deflects supposedly is just like a 10% deviation or some shit. It's not necessarily reflective of the actual deflection you might see, I think. I'm going to go ahead and change the material because this thing was freaking out when I was trying to choose the steel they told me to use. Okay, now that makes more sense. So we got, because I don't know if that steel will have the specification, you know, property specified. It's just the only, this thing kept disappearing for some reason. I couldn't figure it out. But this is a factor of safety of 5.8. That makes more sense. Makes me feel a little better. So no failure points. Okay, so we're going to go back here to the fixture step, and we're going to delete 1. Well, I'm going to take me back to the okay, fuck this over there. I had to go, you know, select it from the tree, like this. I just really want to delete. Let's delete this one. Okay, so that's giving us a much lower factor of safety. You can see the bond misses stress there. So, you know, if one of our supports fails, you know, it still will support the load, but just barely with a lot less factor of safety. And if we get it down to 1, it'll actually fail. So I can go back to our fixtures, edit an existing fixture, but that really doesn't tell me what to do. Go ahead and just delete this one, 2, and then next. There we go. So that was a way of skipping over the rest of it. So, alright, so we do have a failure point, you know, it's 0.7. So you can see, you know, that would indeed fail, you know, just due to overload with just one of them. So yeah, a lot of the material in this database doesn't have the critical data you need to run simulations on it. Creating a new material for this part based on specifications, and of course their specifications are in fucking the wrong units, bastards. I don't want to fucking figure out newtons per square meter versus newtons per square centimeter. Mass density, I mean, like I said, that's just not. Let me see if I can change it. Nope. I'll just use some material, because these assholes are like using some weird variation of CGS on this, and I don't want to have to go convert. That's for just a simple little test. I mean, seriously, it's the last demo. I want to get done with it. Okay, selected this as a fixture. I'm going to apply force. It's going to be a little tricky. I'm going to apply force to this face and to this face. So, but, you know, it's in an outward direction, so that's what we need. So we probably can just leave it normal to that. Shouldn't be any reason to reverse the direction and apply 2 pounds to each face, and then see what material I used. It's one of the few that actually had all the properties defined. A lot of them didn't have yield strength, they did have Poisson ratios. I need to go look that up on the internet and figure out how to pronounce it. Okay, run the simulation. Okay, continue. Got a good safety factor for what we're doing, because it's like a cartridge thing, so you got to be able to pull this out to insert the part, you know, in another fixture. So although this is only deflecting, let me look at the displacement here. Yeah, it's displacing by, you know, 0.02 inches. So it's only 20 mil displacement. You know, It still is under 2 pounds of force, so anyway. Now we're going to go suppress this feature here. Okay, and rerun the simulation. And probably ought to fucking redo it. God damn it. Okay, now I've got a problem with this. Shouldn't have to redo this. Last time I checked, it does have a fucking material, you stupid piece of shit. Okay, yeah, this thing stopped working, so that figures. Okay, that was a pain in the ass. I don't know how you're supposed to really deal with that, but anyway, we're still within limits even after removing that stiffening rib. So that's cool. Okay, we're going to assign copper to this. That's not too pretty. Yeah, we'll put our leave it like that. Really? I don't think so. Okay. Okay. And this little area here, we're going to apply an inward force of 100 pounds. Oh, God damn it. Fucking piece of shit. Ugh. safety factor 2, so we're looking pretty good to make this out of copper. The 100 pounds of force applied. Alright. Now, something like this, it's really ideal to, you know, actually have a safety factor of like 3. So, you know, those are the areas that it would be inclined to fail at with those criteria. Alright, and go ahead and reverse the direction. Rerun the study. Still got a good safety factor for that direction. You know, not good enough, but you know, still good-ish. God, this fucking idiot programmers. I mean, pretty much has the same area, but that would be a buckling position. I'm surprised that, yeah, there we go. It's showing that underneath. Cool. You can see the stress profile is a little different this time. So, there you go.